Hello everybody, my name is Todd. I'm going to be your logic tutor today. Today we're doing more proofs. Now we're using the rules of proper inference and the rules of replacement. Okay, start off easy and get harder as we go. Okay, the goal here on our first problem is to prove B. So we look around in our premises to find B. B is right there in the consequent of line 1. To get it out, we would need an A and then do modus ponens. Okay, it doesn't seem as if we have an A anywhere, but we do have this line to work with here. And we have a rule that allows us to drive the negation through the brackets. So let's apply that rule. It's called De Morgan's. Not A would become A, the or would become an and the C would become a not C. That's from line 2 by De Morgan's. Well, now we can see that we have access to an A in line 3 so long as we simplify, and we can because the operator is a conjunction. So we get A from 3 by simplification. And now with 1 and 4, we can do a modus ponens, and we get B, 1, 4, modus ponens, and we are done. Let's move on to the next. Here, our job is to find not C. Not C is in the consequent of line 1, which means that we have to get the antecedent and do a modus ponens. We're looking for a not A and B, which we don't seem to have, but we can do this one of two ways. Let's do it this way. Look at the antecedent of line 1, and let's apply De Morgan's to it. If we push the negation through, we get not A, and then the and changes to an or, and the B becomes a not B, and the rest remains the same, then not C. That was from 1 by De Morgan's. Now you can see the antecedent of 3 matches what we have on line 2, so we can do the modus ponens and get not C from 2 and 3 modus ponens. So notice that I applied De Morgan's to just the antecedent of line 1, and that's permissible so long as everything else in the statement stays the same. And that's a big difference between the rules of replacement and the rules of inference. The rules of replacement are equivalences, therefore you can apply them to part of a line. Also, instead of messing with the antecedent on 1, we could have simply applied De Morgan's to 2 and got not A and B. And then we could have applied that result to line 1. So there are many ways to do this very simple problem. Let's move to another. Prove not B is our goal here. And so we look for not B, and we don't see one, but there's one in disguise on line 1. If we do modus tollens with line 1, suppose we find a not A, and do modus tollens, we end up with our not B, which is our goal. So to get that, we need a not A. It doesn't appear as if we have a not A until we really start thinking about line 2. Let's apply De Morgan's to line 2. The A becomes a not A, the or becomes an and the Z becomes a not Z. That's from 2 by De Morgan's. And now we see we have the not A that we needed in line 3. All we have to do is get it out by simplification. So 4 is not A from 3 by simplification. And now if you look at 1 and 4, we can do a modus tollens and get our not B, 1, 4 modus tollens. Okay, one more and then we'll take a break. Okay, prove not A if and only if B. We look around, we don't see it. But its opposite is an antecedent on line 1. So if we did a modus tollens, we would get not A if and only if B. So we're going to need the opposite of this, which we find right there. And we should be able to get it fairly easy. It's in an and. Now, people might be tempted to simplify, but remember our simplification only allows us to simplify to the left conjunct. So before we can simplify, we need to move the if C then D to the left-hand side of the conjunction. This came from 2 by com. Then we can simplify, get C then D from 3 simplification. And now look at 1 and 4. Now we can do our modus tollens, and we get not A if and only if B from